Okay. Good morning, class. I have Zach with me, and we're going to be going through the first few problems on the Algebra 1 final exam review. Okay, Zach, can you see the few problems in front of me? The
Yep.
first problem review? Okay, so the first couple are exponential rules. Tell me what you remember, and we'll try to simplify these expressions. 5x y squared in parentheses, and all of that's being cubed. So what do you want to do?
So you have to you do 5 times 2 first.
Okay, Zach, I'm hearing a lot of good things from you. I'm hearing multiply. Is that what you said?
Yep.
You did? Okay. But you're not actually multiplying the 5. You're actually be multiplying the exponents. This is the power to the power rule. So let me give you a
Yeah.
little bit of a. I need
Yep.
to see the exponents on every single base inside of here. So what exponents can I add in?
Well, you can add one after the 5.
Good. That is a base, and also the x. Okay, now do the power to the power rule, Zach. So what am I going to write in the next line? 5 stays the same, but I multiply the exponent. So 5.
So 5 to the second.
Well, 1 times 3. So I'm going to say 5 cubed.
1 times 3.
Same with the x. 1 times 3 again. Power to the power. X cubed. And then the last base that has an exponent is the y squared. So we're going to also multiply that power by 3. So that becomes y to the
6.
Good job, Zach. Okay, I'm going to simplify this a little bit more. 5 cubed is actually something that we can simplify. 5 times 5 times 5.
25 times 5. 125.
Perfect. 125 x cubed y to the 6. Looks like there's no more parentheses. There's no negative exponents. Everything is simplified as far as we can go. Okay. Thank you, Zach. Let's move on to number 2. Okay, the multiplication rule. If we have the same base, we can do a different rule with the exponents. Okay, let's start off with just multiplying as much as we can. The coefficients in front are simply just going to get multiplied like any factors do. -4 times 3 is?
-12.
Good. And the multiplication rule that I was just mentioning means if you have the same base, what can I do to the exponents?
You can add them.
Very good, Zach. X is the base, and we're going to add the squared and the cubed. That makes x to the 5th power. Good. Reminder, this is y to the 1st. So do the same idea, the multiplication rule for the y base. Y to the...
Oh, 6.
Good. That was the multiplication rule for exponents. So we add the exponents if they have the same base. Okay, very similar. We're going to be doing the division rule, which basically means we're going to be subtracting exponents. We have to pay attention to where the exponents are larger, and of course, we have some coefficients in the front. So this is really division, Zach, so go ahead.
Just guessing, would it be 20x cubed and y to
Hold on,
the
pause right there,
5?
Zach. Okay, that is a very good guess because I saw that you subtracted, but these are not exponents. These are just factors. These are just their own base. So I actually need you to do 24 divided by 4. I just need to reduce that fraction.
Oh, okay, that's 6.
6 in the numerator. Good. The 4 would simplify down to a 1, so I'm not going to even write that down. Okay, Zach, the next factor are x's. The next base are x's. Where are there more x's? In the numerator or in the denominator? Where are there more?
Denominator.
It's going to stay there. Nice. Okay. Some are going to cancel out. Do the division rule, which really means subtracting the exponents. What do we have?
Well, what you say?
I had trouble hearing you there, Zach, so I'm just going to answer for you. 5 and 2 are the exponents. So we're going to subtract those and keep it in the denominator. Okay.
Yeah.
All right. And then the last factor, Zach, are the y's.
No.
Y to the first, y to the first. What happens to the y's?
So they cancel out.
Right. If you were to subtract the exponents, you would get y to the 0, but we know that y to the 0 is the multiplicative identity of just 1. So you are 100% correct. The y's do cancel out. Okay.
Again, I'm not having trouble on this. It's just the graphing vertex form.
Oh, okay. Excellent, Zach. Well, let's take a look at number 4 and 5, because before we get to vertex form, that's about transformations. That's about shifting the original parabola around. But first, in these exponential ones, this is number 4. So I need to tell you that like the original one was y equals 3 to the x. So what would happen if I did y equals 3 to the x, but then I subtracted a 1 to the very outside of that? That is considered a translation, and that is done not within the input, not within this expression where the x is, and the exponent is done after. So it's like the k value. So this one is going to be translating vertically. Translate down 1 unit. So this original graph is just going to be moving down 1. Okay, I made up another one just to recap the vertical and horizontal translations. Zach, can you see this one that I made?
Yep.
Okay, if the original one was a simple exponential y equals 4 to the x, then what does that minus 7? You have to remember that h and k values. What direction does adding or subtracting to the x input do to the original function? Yeah, a lot of words there. Okay, so this one was translating down 1. Maybe we'll start off with that. This one is adding 2 to the outside. So this plus 2, Zach, is actually a vertical translation, and this one is going to be not going down, but this one is translating up 2. Then this one, x minus 7, that is also a translation. It's horizontal because it's in the x expression that was substituted into the exponent. This is translating to the right 7. This is what students were getting backwards in the reverse direction because they forget that if you're subtracting 7 to your x value, you're actually translating the same thing to the right. All right, I'm going to skip ahead a couple problems, Zach, because I know you asked about vertex form. I want to take that idea. Oops. Can you still see my screen, or did it change?
Nope, I can see.
Okay, Zach, let's jump to number 9. On number 9, same idea. Y equals x minus 4 squared plus 5. They're asking to describe the transformations. And just reminder, the original one, because when you're describing the transformations, it's being done onto the original one. This is just the original parabola y equals x squared. So what is this minus 4 doing to the original function? And what is this plus 5 doing to the original function? Here's my hint. It's a different type of function, but it's very similar to what we were doing with this exponential function. So the vertex is, that's another way to answer it, but I'm going to describe it with transformations. We're translating. Okay, Zach, is this moving to the right or to the left if I do x minus 4?
to the left.
Unfortunately, you guessed wrong, because if they move to the left, I would have to see a plus sign here. It's x minus h. So that actually means the h is actually a positive 4. The vertex is actually at positive 4 instead of at the origin.
But wait, right there.
Uh-huh.
It's a negative 4. So why are you saying it's a positive 4?
Because, very good question, Zach. The vertex form of a parabola is x minus h. So when I ask you what is the h, I'm not including this minus sign right here. That minus sign is part of the form. So it's x minus the distance that you want to travel to the right.
Okay.
That would be 4. And then this one is the horizontal. I'm sorry, this one is the vertical translation. So this is translating up 5. The vertex would be 5. So let's back up to the form that we haven't seen before. This is not a vertex. I don't want to say it's a vertex, but it was the y-intercept. And now that's translated, and every single point translated 7 to the right and up 2. In this particular case, it's this is one that we were more familiar with, vertex form. X squared, the original parabola goes 4 to the right, even though it says minus sign right there, and then up 5. Okay, let me just show you one more, Zach, just to remind you that if you see a plus sign here, let's mix it up and let's put a minus sign out here. Zach, can you tell me what the vertex, the new vertex of this parabola is now?
So it would be going to the right and down.
You're correct about that down, but Zach, that is an x plus 3. And remember, I wanted to see x minus h. So let me give you another hint. This is like saying x minus a negative 3. This isn't actually a positive 3h value. This is actually a negative 3 in order for it to have the correct form for the vertex form. So correct yourself if you can. What is the vertex of x plus 3 squared minus 8? It's not moving to the right, but it is moving to the left. The vertex is negative 3, negative 8. We translated the original graph 3 to the left and 8 down. All right. So far, Zach, just to recap, we talked about the beginning problems. We talked about the exponent rules. We saw the transformations, mostly translations, but done onto an exponential function. And we reminded ourselves that it's the same idea with quadratics, with number 9. With a quadratic, the translations actually give us the location of the vertex. In this case, it was 4 or 5.
Okay, yeah, I understand.
Okay, that's a good spot for today. Let's meet again soon, and I'm going to end this recording just so people have something to look at. 1, 2, 3, 4, 5, and number 9. Okay, we'll look at the other exponential ones in our next video.
Oh, the exam will be like a Google form.
Yes, it will be on June 9th, which is not too far away now, and it is going to be on Google Form. So there will be choices, but these questions are going to be very similar to what you can expect to see.
Okay.
All right. All right.
Yeah. Have a good day.
Yeah, Zach, you don't mind if I share this with the rest of the class?
Nope.
Okay, I really appreciate it. Hey, have a great day, Zach.
You too.